Hello, this is Jeff Hamrick at Rhodes College, and I'm going to talk for a few minutes about the so-called Coke versus Pepsi taste test that we ran in class the other day. For the sake of specificity, I'm going to focus on Professor Dunwell's class's results. In Professor Dunwell's class, a total of 24 triplets of Coke and Pepsi were studied, and students correctly identified the odd man out in each triplet 16 out of 24 times. And so what I'm going to talk with you about right now is how we determine whether or not that 16 out of 24 times is sufficiently large enough than what we would expect, larger than what we would expect, so that we can reject the idea that the students in Professor Dunwell's class can't tell the difference between Coke and Pepsi. The way we proceed in this new type of situation, which we'll come later to call a single test on proportions, is we're going to create our own collection, and we're going to do so by populating a table. So let me name this collection. Let me rename this. I'm going to call this Coke versus Pepsi. All right. And we're putting in our own data here. And in fact, I'm going to generate the data in a sort of systematic way, like we did in class. The first thing I need to do is fill out the table, so I'm going to add new cases. So because Professor Dunwell had 24 triplets analyzed by her students, I'm going to add 24 cases to this table so that I can replicate, so that I can simulate the behavior of how students might have handled 24 triplets of Coke and Pepsi. What I'm going to generate in this next column, which I'll call the result, what I'm going to generate in this column is a random string, a random word that indicates whether or not the student pegged the odd man out in each triplet correctly or not. So what I'm going to do here is right-click on the top of this column and edit a formula, and my formula is going to be the following. If a random number between 0 and 1 is less than 1/3, if it is less than 1/3, I'm going to call that student's guess correct. If it's not less than 1/3, which means it must be between 1/3 and 1, I'm going to call that guess incorrect. Okay, so let's quickly go over what's going on here. This piece of code is generating a random number between 0 and 1. This is then testing whether or not that randomly generated number is less than 1/3. If it's less than 1/3, I'm going to peg the answer correct. If it's not less than 1/3, I'm going to peg the answer incorrect. Why am I simulating results for an artificial class in this way? Because if students were guessing at random whether or not they could distinguish the odd man out in each triplet, they would be correct on average 1/3 of the time. So that's why I'm using this threshold of 1/3 right here. That threshold will change from example to example that we work through when we're testing single proportions. So I'm going to go on ahead and press OK, and these results will fill in now here. Let me drag down a summary table so we can look at the results. So in this particular set of results, we had 24 triplets analyzed. 19 were incorrect, 5 were correct. If I want to re-simulate the behavior of students working on 24 triplets under the assumption that they can't distinguish Coke from Pepsi, I need to right-click on this box right here, and ask for the data to be re-randomized. So you right-click on this box and you re-randomize the data. Now the results are slightly different. Now we have 8 correct answers and 16 incorrect answers. Let's do that one more time. You right-click on the box, re-randomize. Now there's 5 correct answers out of 24 and 19 incorrect answers out of 24. In the next screencast, we will learn how this initial setup of this table is going to form the basis for a new randomization test that we need.